All right, guys, a few announcements. I need to turn the lights down a little bit in here. If you go to the front page, as of course you will when you log in, from here on out, for anything recorded in October, which starts today, if you turn a lecture in more than 9 days late, it'll be a 0.
9 days?
Yeah. I'm getting things in like that were like 21 days or whatever. So I know that I asked people to get it done within 2 days, but a lot of people wait until the weekend, right? And that was okay with me, really. But, from now on, I want y'all to stay caught up. So, from here on out, 9 days should be more than enough to find the video and watch it, right? So, on the other hand, if I mess up, this happened to Lecture K last week. It's my fault, no penalties. So I'm uploading Lecture K now. Hopefully it's the right one this time. Also, a lot of folks have not taken the Chapter 5 quiz yet. The exam's coming up at the end of the week, which includes Chapter 5, so this isn't great. Also, I am behind on some people's grading, so I need to catch back up myself. So I'm going to stretch the last day that you can take the exam back a week. If we scroll back up and look at the dates of the exams, well, if I haven't posted the date of the exams, here they are. So for the in-class students, the exam will be October 4th. I think we're going to put that off. Let's put that off for a week if that's okay with everybody here. Is there anybody who will not be here next week? And if that's the case, you can take it at the Learning Resource Center at your own convenience. Thumbs down if you don't like taking it next week instead of this. We all good? Thumbs up? A lot of people aren't voting either way. All righty.
No problem.
Okay, so what we're going to do is we're going to make the exam open from 3 to 17th.
So are we still taking it in class, or are we taking it?
We are going to take it in class. The in-class students are going to be able to, and we're also going to do first come, first serve for, maybe a couple of students.
So the in class will be next week, or Tuesday, Thursday?
That's Thursday. Right. So anyways. The exam will be open until, what did we say? Why did I pick? Did I say 3 to 10? Let's make it a 19th. That's a huge amount of time. You don't need to wait that long, guys. Remember, if you put off taking it, right, the material is going to kind of rot in your brain, right? Kind of decays. It's best to get it done soon. As soon as you get done with the Chapter 5 homework, the Chapter 5 exam, go ahead and take it. If you're taking it with ProctorU, then if you, what's the term, subscribe. If you set up an appointment that's more than 72 hours in advance, then you get the lowest rate, so you'll just want to set your appointment appropriately. The only deal about taking it at the Learning Resource Center is that you can't use an electronic version of the book. You can't use a Kindle. Whereas ProctorU, you can use a Kindle version of the book. You just have to install Kindle reading software. And if you're coming to take it in class, as the in-class students are, then you can take it, you can bring your electronic book in. All right, so onward and upward. So the last thing we were doing is we were using string functions. We were using string functions to determine if a string was uppercase, whether a string was lowercase. We were specifically doing just a single character rather than an entire string, but it also works on an entire string. So if you call, where's one of the uppercase one? I'm not finding it. Upper. All right, so if you call dot is upper on a string, or better yet, is digit. If you call is digit on a string, it'll check to see if the entire string is full of digits. If it's not, then it'll return false. So, you know, S is equal to 1, 2, 3. S dot is digit, like that. Well, I was expecting that to print true or false, huh? Oh, it launched the editor rather than the shell. Alrighty. S is equal to 1, 2, 3. S dot is digit. Right? It's all digits. S is equal to 1, 2, 3.4. S dot is digit. I wish it would say true, right? Because it's a number. But it's not. It's counting the period as not being a digit. All S digit does is make sure that the entire string is composed of things like from 0, to 9. All of those numbers. What about things like is upper? S dot is upper. Are there any uppercase letters in it? No. It's certainly not all uppercase letters. Is upper and is lower. Let's find out if it will accept numbers as well. So if we do this, S is equal to Bob in caps, and then I do S dot is upper. If I can type, slow down. There, that is uppercase. Now what if I do this? S is equal to, Bob followed by number. Is that still uppercase? S dot is upper. It is true. So is upper and is lower will accept digits, which is kind of interesting. What if you want to rule out any string with digits? You can do S dot is alpha. Alpha means alphabet. It's got some alphabet characters, but it's also got a 1 in it. So S dot is alpha turned out to be false. So what we did is we wrote a loop that would go through the entire string, like a password loop. Check to count the number of special characters and the number of uppercase letters and the number of lowercase letters and so on. But we didn't actually make it do that. We were just making it print that information out, right? We were printing out uppercase and lowercase and is digit and is space. So what I want to do today before we move on from this topic is to go ahead and write a little bit of a program that would count the number of uppercase letters and the number of lowercase letters and the number of special characters. How do we know if it's a special character? Well, we use is_alnum. That means alphanumeric. Is it a letter or a digit? If it's not a letter or a digit, that means it's punctuation, and we're going to call it a special character. So we may as well go ahead and play with this. Let's go ahead and ask the user for a password. Print. Change your password. Enter new password. And then S is equal to input, right? Now we need some counters. Why do we need the counters? Because we need to make sure by the time it's done that it has some uppercase letters, some lowercase letters, and some digits, and some specials. Usually I make this an assignment, but I don't think I'm going to make this an assignment. We're going to do this one in class. So we need to do some counters. Digits is equal to 0. Specials is equal to 0. And by the way, if you took my fundamentals class, this will probably seem familiar. Specials is equal to 0. What else? Uppers is equal to 0. And lowers is equal to 0.
We did the passwords in the last class.
Did we do the whole password thing?
Nope.
Okay, pardon, what was the question?
We didn't do the passwords in the
Oh, we didn't do it in fundamentals? Okay. I was lax. Alrighty. So I think this is enough, right? Uppercase letters. A password must consist of one of each of these, and it has to have a length greater than 8. Okay, so we're going to write our rules here in a little comment. I don't care if you do, but it's useful. I'm going to put 3 quotes there. Rules. Password must be 8 or more characters long. Why don't I just abbreviate it to chars? Must have at least one upper one lower, one digit, and one special. All right, and then 3 more quotes to end our comment. I think we ought to declare as a constant the minimum length, right? So that later on, if we decide our passwords need to be 20 characters long rather than 10, heaven forbid. So how about min_length equals 8? So these are our counters, and we're going to have a loop, and every time it finds a digit, it's going to add 1 to it. Whoopsie, get lost. Every time it finds an uppercase letter. So we need a for loop. There's more than one kind of for loop. There's the index-based for loop where we use a range statement, or then there's the value-based for loop where we do for something in something, where it's a string or a list. The second one's easier to use. So let's do that. For ch in s. Now s is a really lousy variable name. We ought to go ahead and change it while we're at it, because we're not going to have to type it too many times. So why don't we do this? Why don't we change that s up there to the word password, and let's do it here as well, because we're only going to use that a couple of times. So before our for loop or after it, we're going to need to get the length. I say let's stick it before it. Length is equal to password, no. Length is equal to len parentheses password. And then now inside our loop, we're going to check, and if it's a digit, we're going to add 1 to it. If it's a special, so which one checks for digits? If ch dot is digit, then add 1 to special. Excuse me, add 1 to digits. Digits plus plus. Nope, wrong language. Digits plus equals 1.
Can you raise it up a little bit?
Yeah, why don't I do that? My mistake. Alrighty. That about good? Okay. Now we're to check for uppers and lowers. It's going to be dot is upper, dot is lower. Now there is no is special, so what we're going to do is if not is alpha num meaning alphanumeric. So anyways, if ch dot is upper, then uppers plus equals 1. If ch dot is lower, lowers plus equals 1. And then if not, or we could just do equals equals false. I like both syntaxes. So how about this? If ch dot is alpha num, alpha being ph, that means alphanumeric, it's a letter, equals equals false, but false has to be uppercase F. Then specials plus equals 1. Now instead of doing equals equals false, we could do this. If not, right, like that. Either way works. Just pick a way that you like. And the more experienced programmers would prefer for you to do it like that. I kind of like the equals equals false. I like to avoid the not keyword. That kind of hurts my brain a little. But okay, so we've written our loop. I'm going to scroll back up and make sure we have filled in all of the variables. Length, digits, uppers, lowers, and specials. Did I have any others defined? Pardon me while I hit upper. Digits, specials, uppers, lowers, and length. Yep, I think I got them all. Or did somebody see one that I'm missing? We good? Or did I goof? Pardon?
We have to check the length.
Right. We've calculated the length, but we haven't checked it yet. So let's write our rules down here. If the length is less than max underscore, wait, what did I call it? Min length. And let me guess, I put an underscore between min and length, and I can't type. Min underscore length. I'm going to scroll back up. Yep, min length. All right. So I feel like building an error list. And what do I mean by that? Each time we find a problem, we're going to tack on something to our error list. No, we're not. No, we're not. All right. So if length is less than min length, then we need to give them a warning. Print. Password must be %d space chars long. End quote. Now it's not a comma like it is in some language. Instead, it's a % sign. And we're going to do length. And that's a tacky way of doing it. In Python 3, we should be using .format. I still haven't broken the Python 2 way of doing it, which is using a %d, and the %d gets filled in with that variable. All right, so if that's wrong, great. Elif, let's check the digits. If elif is, elif digits is equal to 0, then it's another problem. Print password must have at least one digit. Now I'm going to copy that error message because I'm going to wind up using it over and over, right, for the other categories. Then elif uppers is equal to 0, then it found no uppercase letters. Print password must have at least one uppercase letter. Elif, we're going to check for lowers. Elif lowers is equal to 0. Print password must. If we go to, why didn't I just paste what I copied? Yeah, copy, paste. Password must have at least one uppercase letter. All right, must also have one lowercase letter. And then one final elif to handle the specials. Elif specials is equal to 0. Paste. Password must have at least one punctuation or one symbol. And then finally, one final else, which is to print, okay, good password. Now really we ought to loop until they, until they enter a good password, that kind of thing, but I think this proves the point. The real point of this one is the string functions. I certainly want you to know length and digits and uppers and lowers and specials. All right, now one final check, just to be silly. We're going to check to see if they actually put the word password in their password, right? Because that's the world's worst password, besides just putting your name in there, or maybe it's worse than that. So we're going to say if password, end quote, in password. This was in quotes because we're looking for that string inside the password. Print illegal password or illegal word found in password, something like that. And you've seen that kind of thing, right, where it tells you can't use your first name or your last name in it, something like that. Like say our name is Bob. Elif, quote, Bob in password. Print, no Bobs allowed. We're getting silly, right? But there we go. The reason I'm showing this syntax is because this also works for lists. If you want to see this, if you want to check to see if something is in a list, you can do it like that. All right, I'm going to test it. I'm going to run it. I believe this is Lecture M. All right, let me close that. All right, enter a new password. Password 1234 exclamation point. Now, ooh, it blew up. It's not is alpha num. Does anybody off the top of their head remember what it really is? Alnum. Right. Okay. It's supposed to be alnum. My mistake. So scroll up to where it says is alpha num and just change that to is alnum. I'm going to put a comment out here. Alnum equals letter or digit or number. So we changed that one in our for loop. Let's see if it works. All right, enter your new password. Password are cool 123 exclamation point. Right, this is supposedly a good password. It's past the maximum length. It's got some caps, some lower cases. It's got numbers and punctuation. So it says, okay, good password, but then it says illegal word found in password, right? It gives a, we didn't write it perfectly. Most basically, I was just showing you how to use the IN keyword. So we could change these error messages to something else, but I'm just going to leave that alone. Or we could tack them on, right? And we could put our final else down here at the bottom. Let's do that. Let's make this actually look good. I'm going to cut this else and this print statement and take it to the very bottom, paste it, and then I'm going to change that if password and password. I'm going to put an EL in front of it so it says elif. And then I'm going to delete those two spaces. So EL, delete, delete. All right. Check it again. Enter your password. Password 1, 2, 3, or whatever, some uppercase letters, and it says illegal word found in password. All right, now I'm going to check some of the other ones. What if it's all lowercase? Bobby. Well, password must be 5 characters long. I goofed there. What should I have printed? I didn't want to print the link there. So I need to scroll up to where we print this out. Password must be characters long. Where should I print it? If I print out length, it's printing out 5 because it is 5 long. And then we're scolding them and saying it must be 5 characters. That's kind of dumb. What should it really be? Yeah, it needs to be min length. So change length to min length. All right. Password must be 8 characters long. Here's where it'd be a good idea if it looped, so I wouldn't have to rerun it each time. All right, that's more than 8 characters long. Must have at least 1 digit. All right. Must have 1 uppercase letter. All righty. Must have 1 symbol. All righty. All right, this says okay, good password. Now, good luck remembering the one that I just typed in. Anyways, maybe you have a password manager installed on your browser. All right, so the point of that was to use the string functions. To use is digit, is upper, is lower, is alnum. I hope you remember slicing, like if we want to take the first 3 characters out of the string. First 3, how about just first 3 with a number? And I better stop and make sure there's no people aren't getting typos. But first 3 is equal to password 0:3. And then the rest of it is equal to password 3 : all the way to the end. And let's print the first 3, and then let's print the rest. So when it says 0:3, if our password was, I'm going to add a comment here. If our password was, Sammy, what is it going to print for the first 3? Okay, well, obviously, first 3. I gave the game away there. But that's character 0, that's character 1, that's character 2, but this is exclusive. This is one pass where you want to stop. So it's going to print SAM. Another way to think about it is take the difference between those two. 3 minus 0 is 3, so starting at 0 and going out 3. So if we did this, if I said password, 2:4, how many characters long is it? It's going to be 2, and it's going to start at position 2. So that's 0, that's 1, and that's 2. Okay, so another thing to do is to count the number. Like if our password for some reason has to have 2 spaces. Instead of adding another check here to count the number of spaces, I could just do this. elif password.count parentheses quote space end quote is less than 2 colon. We're going to print password. How about we do greater than 0 and not allow a password to have any spaces in it? So if password.count space end quote is greater than 0, we're going to say password must have no spaces. Like that. So you can use .count, and it doesn't just have to be one character. Now we could have looked for the word Bob, right? That'd be another way of doing that IN thing like that. I'm going to undo that and go back to a Bob. To a space. And along with .count, you can search for a specific string and have it return the index where that string begins. Oh, where did that go? So now we're really curious. What character, what index value that string Bob begins at. So I'm going to do BB for Bob begins, or BIN index, B index for Bob index. Maybe I'll just write out the whole word. Bob index is equal to password dot find parentheses quote Bob. And then I'm going to print a message just saying Bob found at index end quote comma Bob index, like that. All right, so I am going to type something with the word Bob in it, but it's not going to be the first thing. All right, and so Bob was found at index 6, right? 0, 1, 2, 3, 4, 5, 6. That is correct. What if it wasn't found at all? What's it going to return if it doesn't even find Bob in it? 0 would be a bad choice, right? Because 0 could be a valid place for it. Take a guess, somebody. Doesn't matter if you're right or wrong. It's going to return a -1, I believe. Yep. -1 means it didn't find it at all. Right? Because if it found it at the beginning of the string, it would be 0. If it found it the second character, it would be a 1, and so on. But if it doesn't find it at all, it's going to be -1. And I've already made this list for the last notes, string dot is upper, string dot is lower, string dot is digit, string dot is alnum, you know, string len string gets the length of it, you know, x in string searches a string for that thing, s dot count x returns the number of times x appears in S. And then find, s dot find x returns the index of x in S, or -1 if not found. That may be enough about strings. See, if I was awesome, I would make y'all turn this into a program that loops until it finds a good password. So I'm going to make that an extra credit assignment. I'll give you the details at the end so you don't have to work on it right now. I know some people would. So I think we're just about done with chapter 6 at that point. So we've looked at the string methods. Oh, there are more. How about replace? Replace is incredibly cool. Then there's also starts with, which makes me think that there's going to be an ends with. And then one of the most important ones of all is split. I mentioned split when we did the IP address. So starts with and ends with are pretty easy. Right. S dot starts with X returns true if S starts with X. Same for ends with. S dot ends with. I'm not going to even give it, you know what that means. S dot split. Splits the string and returns a list using X as the delimiter. For example, if you do this, string is equal to, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then you do this, L is equal to S dot split. And you say, I want you to split based on those spaces. Then by the time you're done, L will equal 1, 2, 3, 4, 5, 6, and then 7, 8, 9. So you saw what it did. It took this simple string, it split it up based on the spaces. Now when I did the IP address, we did a split based on the period, right? So that we could get, each number. Now these are still strings, so you couldn't do math on them. But you can convert them, using int or float or whatever you needed to do to get them to work. Split, incredibly important. So often you will get a string and you want to turn it into a list, especially if you're reading a file. You read a file, you're going to get into a string, and then you'll have to turn that string into data somehow. And so you will split it up. And replace. Replace is a cool one. If you do this, well, heck, I'm going to go ahead and type it into my Python shell. S is equal to, fun. And then S dot replace all F's with W's, just for some stupid reason. 1. You saw what it did. If we'd had more than one F, it would have changed them all to W's. Now you can tell how many to replace. replace. You can say, okay, only replace up to the first 3 or something like that. You just add another number there. Now notice that S has not changed. It did not change the original data. It returned a new string. Now, do you remember last week where I said strings are immutable? They cannot be mutated. Well, you know, it did not replace anything in the original string. Instead, it returned a new string. But that's okay. You could do this. S is equal to S dot replace. And I'm going to replace that U with something. How about the word wowzers? Dumb, but whatever. And then when I print out S, it says F wowzers N. So S dot replace X comma Y returns a new string with all occurrences of X replaced with Y. What if you want to convert it to uppercase? You call dot upper. So if I go back to my shell and I do S dot upper, all of a sudden all the letters are uppercase. Now, did it change the original data if I just print out S? No. But it returned a new string where everything was uppercase. How about S dot lower? Returns a string where all the uppercase letters have been turned lower. And it doesn't touch digits or anything, right? If we do S is equal to, you know, Bob 1, 2, 3, and we do S dot upper like that, it's still going to say Bob 1, 2, 3. It's just going to be uppercase. And if you wanted to store the result back into string, if you wanted to make the change permanent, you do S is equal to S dot upper, or S is equal to S dot lower, or whatever. Those are worth putting into our notepad. S dot upper makes all letters uppercase, or returns a new string with all letters made uppercase. And the same thing for S dot lower. Returns a new string where all the letters are made lowercase. And strip. What if you have spaces at the end or the beginning, or you have any /n characters, and you wish that it didn't have new line characters at the end, or you wish that it didn't begin with spaces or end with spaces? In that case, you call dot strip. And if you call dot strip, it returns a new string with the spaces and the \ns and the tabs all removed. So S is equal to, you know, la la la, \, oh, whoa, 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 whoa. I guess I can't hit, where's the / key? \n, right? And then like this, and then hello, and a couple more, and a \n, and a couple more, like that. Now if I print S, it's not going to be too pretty. Or actually, that's okay, isn't it? But if I print S dot trim, strip, excuse me, it's trim in another language. Print S dot strip, right, nice and clean. Removed all the spaces and \ns and tabs from the beginning and the end. Now, what if you only want to trim the stuff at the end? You don't want to touch the stuff at the beginning, but you want to, in that case, you use R strip, meaning strip from the right. And if you want to only strip the stuff in the left, you use L strip. I'm going to tack that onto our notepad. S dot strip returns a new string with all white space from the beginning and end removed. S dot R strip, same thing, returns a new string with all the white space from the right, the end, removed. And so L strip does the same thing. I'm just going to copy and paste the explanation. all white space from the left, which is the beginning, removed. So parsing a string, say if you have something like this, and you want to find the position of the @ line, of the @ symbol. Well, you can find the position of the @ symbol. And then you might want to take all the data up to that @ symbol. And let's play with that just a little bit. Let's add something to our code. So I'm going to make a variable called address is equal to, HTTP : and I'm going to use forward slashes just because if I use backslashes, then they're treated as a special escape sequence. And then www.rose.edu. Now I want to get only this part. That's the only part that I'm really interested in. So I'm going to say CIT. Well, first I need to find the position of the, well, now I wish I'd made it. Sorry. I'm changing the example. I'm taking all the backslashes off completely to make it easier to do this. And so the CIT, we have to find the position of the colon. So I'm going to say colon is equal to address.find, and please find the position of the colon. And then we want to return, we want to print, we want to store in our CIT variable a new string consisting of that position going all the way to the end. So how about that? Address. Now there's actually a problem with what I've done here, but we'll fix it in a minute. Starting at the position of the colon and going all the way to the end, so I'm not going to even specify a second value. Remember, if you leave off the number after the colon, it means go to the end of the string. So slice from colon to end of string. And then I'm going to print the CIT out. CIT equals, end quote, comma, CIT. Now when I run it, I'm not going to like the results. Can anybody tell me why? What is it going to print? Well, what is the position of the colon?
It's just the colon.
Yeah, it's going to include the colon. We don't want to print including the colon because, yeah, it's going to start at position 4 and go to the end. 0, 1, 2, 3, 4. It's going to start there and go to the end. Now, what if there wasn't a colon? That would be an error. But anyways, I'm going to say colon is equal to that, and I want to start at position colon plus 1. Now my comment is off. Slice after colon to end of string. Or it could blow up. How about if I don't put comments in my code? Was that stuff really supposed to be part of the notepad? Let me go look. Yeah. Yep. Okay. If you typed that because I did, comment them out or something. All right, change your password, blah, blah, blah. And the site is www.rose.edu. What if it didn't have a colon in it? It's not going to look real good. Actually, it may look just fine, because what does .find return if it doesn't find the string? It returns a -1, and -1 plus 1 is 0. So it's going to go from the beginning of the string to the end. So if I take this out, it's actually going to work okay. That was an accident on my part. I hadn't thought that through. But yep. So That's called parsing. Parsing is when you're taking apart a string to find the individual components of it. And I have one tutorial where we go and we open a website and we search for the price of coffee. And if you've taken Donna Wilson's programming course, I'm sure she had you do that. So we need to learn how to open websites and to pull data off of it. Today is not that day. Anybody need typo correction? Pardon me? Do I need to scroll up?
Yeah.
All right. Say when. Okay. The format operator, we've been using that. %d means that it should be turned into an integer. If you're just going to do one string, you know, s, say we want to print something that looks like this. My name is %s, and we have a first name and we have a last name. Well, if it was just one name, it would look like this. F name for first name, right? But you don't use a comma there, you use a % sign, and you take the quote off. All right, so that's just printing one name. But if you print two names, you got to enclose the parameters like that. So if I wanted to print my name is %s, like that, then the way you read this is going to accept the first variable. This is going to accept the second variable. And then the % sign followed outside of the string says, okay, and here comes the set of variables that are going to fill in the placeholders. Now there's also dot format. Dot format syntax may look a little bit clearer than this.
Now, why would you do that instead of just using first name and last name in the string? Like
Very, very good question. Why in the world would you do this? Well, I'll try to give you my one of my examples. And that's basically if you want to format your columns so that your data lines up. So just scroll up to the very top of your code.
You think on a list?
Yeah, that would be a good idea. We could make two lists. FN for first names, and just put some names in, right?
Or a dictionary.
Nah. Bob, Sam, you know, make some of the names of long, you know, Emmanuel, you know, Joseph, like that. All right, now I'm going to make some last names. You know, Roberts. Come on. Roberts, end quote, comma, White, end quote, comma, Johnson, end quote, comma, Tyler. So now I want to print those things out. I would need a loop. These are what are known as parallel arrays, parallel lists. They are two lists of the same length, where the data is thematically linked by their index number, right? Bob Roberts is at index 0. Sam White is at index 1. Emmanuel Johnson is index 2. And Joseph Tyler is index 3. So, for I in range, I'm going to cheat and just use 4. I'm going to hard code 4, even though that's terrible programming. And then I'm going to print FN, comma, that was supposed to be LN. I don't know where I came up with NS. LN for last name, right? I just changed that. So print FN, comma, LN. All right, so when I run it, it's going to look okay. No, it's not. How do I specify that I only want one position in FN and not the whole list? I just want the first value. I wanted to print Bob. What am I going to do?
FN subscript I.
Yep, Fn subscript I. And the same thing here, Ln subscript I. Yeah, I did that error on purpose. No, not really. All right, and so it printed Bob Roberts, Sam Emmanuel White, Joseph Johnson. All right, I made a boo-boo here. Anybody see the error? Why did it print Sam Emmanuel?
No comma.
No comma, so go ahead and put your comma there. All right, but what if I wanted them lined up, like on a table, right? You know, kind of like an Excel spreadsheet or whatever. What if I didn't want them to be jagged like that? I could fix this print statement so it was like that. I'm going to comment this one out and change it. Print %10s space %10s end quote %, and then inside parentheses I need to list the variables that are going to fill those in. So a close parenthesis, excuse me, an open parentheses and two closed parentheses, and inside here I'm going to put the same stuff I had here. Fn subscript I and Ln subscript I. Fn subscript I, not you, comma, Ln subscript I. Now they'll be lined up. Each one occupying 10 spaces. You know, and if we could count them out, we'd find that out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right, like that. And then there's an extra space there because of that. And then it does that. And what if they're floating point numbers? You can specify the number of decimal places. Because if you print out a floating point number that's equal to 2, then it's not going to print any decimal points. But what if it's supposed to be money? We like to see 2 decimal places. We like to see the dollars and cents. So we can do that. Print, quote, $, and now we're going to use our placeholder, which begins at %. %.2 F for floating point value. End quote, comma, and then let's put in some number, 4.56, and then just copy and paste that and put in some different numbers, like just 4.6, and then once more time, just with 4. And I've already made another serious mistake. What did I do wrong? I keep doing this to y'all. Not supposed to be commas, it's supposed to be %. My brain is still stuck in some Java programming universe. Here we go. And you see what it did? Each one of them is printed out with 2 decimal places. That's what the .2 means. And so these formatting strings, this will be about the last thing we do. Formatting string, or format placeholder, begins with a %. Then if a digit follows, makes the data that many characters wide. In other words, it pads it out with spaces. Then if a decimal followed by a number follows, format the floating point, or format the number to have that many decimal places. And then followed by either S, F, or D, where they mean string, float, or int, like that. Now if you start trying to do this dot thing, like that, but it's not a floating point, it'll give you an error. You can only use that dot stuff to print out floating point numbers. So you do have to specify the type of data. These are strings, so we did %10s. If we wanted the things to be wider, we could make that number wider. When I run it, the data looks kind of cool, but it's right justified. What if I don't want it right justified? I could fix that by putting a minus sign after the % sign. So if I do % -10s, and percent minus 10s, then the numbers are going to be left justified, right? They're going to be pushed to the left rather than the right. Just depends on how you like it. I don't know why it defaults to being right justified. I'm going to take those out. I kind of like it like that. Right justified. Makes it look fancy. So anyways, that's why you use the formatted print statement. Does that make sense?
Yeah.
Yeah. About time to stop. I wanted to get done with this chapter. Yeah, we're done. Okay. All right.